Hello, students and my dear viewers. How are you? I hope you are all good, all fine, all having a nice time. I was teaching you, uh, I mean, uh, this very interesting topic called ceramics, right? So I'm back again with something new. First of all, I would like to explain, remind you about the things I've just explained you people previously. These were the types, or you can say raw materials that were used for ceramics. I just told you about their percent purity and the materials that are basically used in them and the category wise what they are. So they were a bit, you can say, they were crude materials, and they were they were percent purities were described as variable. The materials, what type of materials were included in it were shale, clay, crude bauxite, crude kyanite, right, and natural ball clay. These were all the examples, right? Whereas if we'll talk about the other one, it's mineral, industrial minerals or refined crude materials. These includes almost 85 to, their percent purity was almost reaching 98%, and they include pyrophyllite and talc and feldspar, kyanite and bauxite, zircon, and there were calcined kaolin and dolomite. So these were the materials that are used in it. So these were the few things that I explained you previously. So today I will come up with something new, that is the raw materials that are used, or you can say the functions of raw materials used for ceramics, right? So first of all, I would like to tell you stepwise what are the functions of the different elements that are there. So I was telling you about the functions. First of all, the functions of raw materials for ceramics. So functions of these includes function of clay, functions of feldspar, and functions of silica, and functions of talc, right? These are the four functions, main basic functions that you are supposed to memorize, that you are supposed to learn, that you are supposed to learn by heart, right? So what could be the function of a clay? Of course, clay serves as a binder, right? It serves as a, you can say, suspension aid, right? And it is an inexpensive source of alumina, and of course silica is along. When alumina is there, silica is there, and it is the most important element in the ceramic tile body, right? Now what could be the functions of this clay are? It produce a light, coloring and firing, right? And it gives plasticity, binding characteristics to the mass. It produces good flow properties, right? And it improves mechanical characteristics in the tiles. So these are the few functions that the clay performs, right? It provides a good density level, right? It is also one of the very important functions, that it provides a good density level. It is also suitable for manufacturing of china clay, right? And porcelain. It is also one of the basic functions of clay, so this was the function of clay. Now I'll teach you the function of feldspar. Function of feldspar, it's a very important, and you can say it's a very essential and common fluxing material for ceramic bodies, right? Especially for the ceramic bodies, it is very important, and it gives a glossy finish, as I just told you before in my last lecture. Glossy finish to the ceramic bodies, right? It plays a vital role in attaining vitrified and high mechanical resistance of the product, right? This also includes its function, that is functions of feldspar. We are talking about feldspar. Now, whereas the functions of silica, if we starts the functions of silica, it is also, you can say, one of the raw materials, right? And it's very, very important raw material. It simply facilitate, or it make it easier for the gases to escape during the drying and firing process. Now what is firing? I told you this is not that firing. It's not that firing, okay? Keep that thing in your mind. Those who were going through the process of glossary, going through my lecture of glossary, they know what is that. So please go through glossary, right? So that you will understand the basic terms that are used in ceramics. It reduced drying shrinkage and increased the wideness of the fired body. This is also one of the functions of silica, right? And it often used as a filler So I was telling you the functions of this silica, right? So it simply facilitate, or it makes it easier for the gases to escape and during the drying and firing process. And it reduces, as I just mentioned, that it reduces drying shrinkage and increase the whiteness of the fired body, right? And it is often, the silica is often used as a filler, and I told you what is a filler in the glossary. Just find out what is the meaning of filler, right? Because these are the very specific terms, and they are not, in our daily, vocabulary, they are not used as a daily vocabulary. So students find them a little bit difficult to understand what is firing, what is body, what is kiln, what is calcination. These are all the terms that are basically related to only this chapter, that is ceramics, right? Ceramic industry, or ceramic, and the raw materials that are used in it. So we were just talking about all these things. So silica is also used as a filler, right? And it acts as a glass former, also as a glass former. Now what is a glass former? You might be having a little idea what is a former. We just discussed the formers, fluxes in our last chapter, that is the chapter of glass, right? I explained you what is that, so please go through that also. So it is also it can serve as a glass former, right? Now if you discuss about the functions of talc, 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 it is used in very small minimum amounts, right? And in a vertified body, right? Whereas it elevates fluxing action, the action of flux, it is enhanced, right? And is formed with the, simply when it gets in contact with the water, to improve the whiteness level of the product, and lead to a, you can say, a very higher modulus rupture of a fired body, right? It acts like that. So this is the basic function of this talc, which I just mentioned you. So these were the four different categories that were explained in this section for you to understand easily, and I hope you got my points and you will learn them now easily, and you will go through all the details that are I just explained you in the functions of raw materials, right? Now used for the ceramics. Now all these four are very important, and you are supposed to learn them nicely. I hope you will do it. So I'll start with the next thing in a few seconds. Now I come up with a new topic again. It's a manufacture of ceramic products, right? And chemistry that is involved in production of ceramic articles and wares, right? So now most of the traditional and technical ceramics or ceramic products are manufactured by compacting powder or particles into shapes, right, which are heated to a very high temperature or a very elevated temperature. Now they consist of four basic terms. Now what are those? Or you can say they go through four different stages. What could be those four different stages? Number one, shaping. Number two, drying. Number three, firing. And number four, glazing. These are the four different stages that it has to go through, right? So now if we discuss shaping, what it could be, the ingredients are mixed together simply, right, and are soaked in water. They will be kept in the water or soaked inside the water for some time. And then water is added, more water is added to increase the plasticity of the clay. It becomes a more elasticity or plasticity, right? The increase in water is the, or you can say the excess of water or the extra water content is squeezed out, right? It's sucked out to make a clay, right? And with only a moisture content that is left, about 20% is there, and the mixture is then shaped appropriately, easily. Now this is how it could be done. This is either done by forcing the clay into mold, right? You will shape it into a mold form, or by simply pressing a mold into the clay while it is spinning on the turntable. It is a turntable that where it is constantly spinning, and that mold is spinning for about 2.5 to 1 hour, right? So these includes few processing techniques. Now I'll discuss in my next video the processing techniques that goes that goes on when we are discussing the shaping of ceramic manufacture. So this injection molding process, in which the raw materials are simply mixed, thoroughly mixed with the resin, right, to provide them a fluidity degree, right, that is, it becomes a fluid like mass, and then finally it is injected into the mold, die or molding die. It is injected into it after this process. Now the step 2 of that is drying. What is drying? The items are dried slowly, right? They are very dried in a slow manner. In some sort of oven is always required, which they lose all the water, that is the water molecules, just to escape the water molecules, get rid of water molecules, and which are bound up in crystal lattices, right? So and before the ware can be fired to high temperature, it must be fired, first be dried to remove the water. This is essential, that the water molecules supposed to be removed before it is again put back to that fired process. It is kept back for that fired process. So before that, it is supposed to be kept in the oven to dry the moisture into it, and that is the only technique to dry the moisture. Then put them in the oven, or either put it in some, you can say, you can put it in some jar and you can put some silica inside it, and you can get the moisture removed from it. So that is also one of the processes. Well, so this was something interesting. I hope you have understood this thing. So I just explained you what is tape casting, slip casting, and injection molding, and I explained you the drying process also. First was the shaping process, the second one is the drying process, then firing and the glazing. So I have explained you a few steps of the drying process. Now 3 to 7% of volume is reduced in this drying technique, or this drying process. Okay, now if we'll discuss the step 3, that is the firing. Now the item is heated in this process. The item is heated to the temperatures around up to 170 or 1170 degrees Celsius, and which time the clay undergoes some chemical changes. Definitely at high temperatures it will go through the chemical, its composition will be a little bit disturbed. It will go through some chemical changes, and the silica and feldspar undergo physical changes too. These two will be physically, they will be a little bit different. The process of firing or pot creates cross links between the hydroxyl groups, right, in the clay oxides of the first row transition metals, whereas which are the main sources of, you can say, color in the pottery glazes. These are the main source of color that is produced in these pottery glazes, right? So the reactions of clay are very interesting, and they can be named as chemical reaction of clay. That is, the temperature must be controlled as the clay decomposes. So a controlled temperature is needed. That is Calorinite. It can decompose, so it will simply turn into Calorinite, and then that is it has a very high, it goes to the high temperature, that is 500 degrees almost Celsius, and then it turns into silicon spinel, that is around, it has a temperature around 925 degrees Celsius, and then finally to a mullite, whereas it is has a higher temperature and more temperature, that is around 1100 degrees Celsius. So silica and water from the crystal lattices are also expelled. They are also expelled during the firing process, resulting into 5 to 7% of the volume reduction is there. So the driving off of this chemically bound water mechanism is very interesting. It's simply clay plus again you add up clay, and you will get again a clay, and then you will get water, of course, plus some water of the water molecule is there, that is in grams. As you can say, the weak hydrogen bonds are replaced by the stronger, or you can say shorter oxygen bridges that are there. The clay may shrink a little bit more further, and with this the clay can no longer be recycled as this. When this happens also, that the clay cannot be recycled. So it could link the neighboring clay particles is a gradual process, and if the firing is stopped at around 500 degrees centigrade, enough of these cross links will be formed to prevent recycling, right? So but not enough to strengthen the piece of that, so that's it. at the same time, the Calorinite, it will simply lose its crystal structure. It's lost, right? It has a thin regular sheet of the crystal structure, and it is lost. And what will happen? It will turn into an amorphous metacalorinite structure, and that is almost these spots can be classified according to the temperatures they have been fired. That is earthenware around 1000 to 1150 degrees Celsius, whereas the reaction stoneware and porcelain, they have almost the temperature range around greater than, not around, but greater than 1200 degrees Celsius. So now if we'll come to discuss the next part, that is the reaction with the silica, chemical reaction of silica. Silica will do not decompose at the temperature encountering in firing kilns and melts at 1725 degrees Celsius. Now if we'll discuss the chemical reaction of feldspar. The pure feldspar begin to melt at about 1140 degrees Celsius and to form a very solid and a viscous liquid, and as the temperature is again raised to a higher level, it decomposes to form more liquid, right? So it's like that. And now the step 4 is glazing. Glaze is a thin layer. Again, I told you what is glazing. It's a thin layer of glass glass and crystals that adheres to the surface of the clay body. Now glaze or glazes are composed of various number of oxides combined in different number of proportions, right, that will yield the desired properties. Silica, silicon dioxide and boric oxide and B2O3 are the glass formers, but oxides such as Na2O, K2O, C8O and lead oxide and aluminum oxide must be also be there in the stoichiometric sense, right, to give these all desired products. So these now all include, for example, now lowering the viscosity. If you now, what is viscosity? Another physical term, viscosity. It's simply the internal resistance of the liquid to flow, that is called viscosity. This is the definition, simple definition of viscosity, that internal resistance of the liquid to flow is called viscosity. How viscous it is, right? So honey is viscous. This is also one of the examples. Water is not viscous, honey is viscous, right? So this comes from viscosity. So now these all includes lowering the viscosity of the molten glass, right? If you just reduce its viscosity and of that melted glass, and that glaze will flow smoothly over the surface of the clay body at that temperature and at which the glaze is fired. Now the glaze is either applied before firing or between a first and second firing, right? Glazes are glassy substances, you know it very well. These are glassy substances that they're used to provide a very smooth surface, smoothness to the item. It provides very smoothness to the item, which can then further be textured if necessary, and ceramic surface can be colored afterwards. So now the color of glazes include, for example, cobalt. Cobalt is used for the blue color, that is CrO3, used for green color, and Fe2O3 used for the red color, and PbCrO4. I'm telling you the formula so that you can easily go through learn the formulas also. For the yellow color, that is PbCrO3. What is PbCrO4? You should tell that first. Okay, it is now for the yellow color, and combination of COO blue and Cr2O3, that is green, and magnesium oxide black, used for black, only for black color, right? So these are the different, these were the different glazing steps that I just explained to you, and the color of the glazes that are formed after that, I just explained that also. So this now completes your almost the chapter of your ceramics, and I think I was quite successful in explaining you ceramics. I hope you will enjoy learning this chapter from my lecture series, and if you don't understand anything, please mention in the comment section so that I can explain you again in a nice way. And please cover all this, learn this by going through the lecture again and again, because when you will go through the lecture, you will come to know what are the steps, and do compare it with your with the stuff that is provided to you in the notes form, so that you can easily compare both the my lecture with the those papers that are given to you. So I will see you next time in my next video with a new topic. Thank you so much. So the process of shaping, it includes the following processing techniques, that is tape casting, slip casting and injection molding. These are the three things. What are those three things? Number one is tape casting. That is tape casting. It is a process for making these very thin sheets of ceramics using ceramic slurry. And what is a slurry? Again, a new word. Consult glossary. Okay. So a ceramic slurry consisting of what? Of course, binders, right? And plasticizers. These are the two basic ingredients that are used for this tape casting, right? Now, number two is slip casting. Now, what is slip casting? It is forming a hollow ceramic part by introducing a pourable slurry into a mold. A mold becomes pourable. I mean, it is consistency in such a way that you can pour it, right? And it is a pourable slurry, and that you will simply pour down into the mold. That is the shaping mold, right? So this was one of that. Then the third one is injection molding. Now, what happens in this process? These raw materials are mixed with the resin. Some sort of a resin is there. What is a resin? So please go through what is resin. It's very important term and very easy to understand. I can explain you if you don't follow what is a resin. So now in this method, raw materials. Now what are raw materials? We just discussed those are mixed with the resin to provide the necessary fluidity of process or fluidity degree to provide it the basic fluidity degree, and then it is injected into the molding die. Then finally it is injected into that die.